Why does the universe exist? This is one of those questions that sounds almost childish at first, but the more you think about it, the stranger it becomes. We are used to asking why ordinary things happen. Why did it rain today? Why did a stone fall? Why did the sun rise? But the question of the universe is different. It is not asking why one thing happened inside the world. It is asking why there is a world at all. Why is there something rather than nothing? Humans seem to be almost alone in asking this. A cat does not look at the night sky and wonder why reality exists. A bird does not ask whether time had a beginning. But we do. We look at the stars, and instead of simply seeing lights in the sky, we start asking impossible questions. For thousands of years, people have tried to answer them. Philosophers, priests, astronomers, physicists, and ordinary people have all faced the same mystery. Some said the universe was created by gods. Some said it had always existed. Some said it came from chaos. Some said the question itself may be wrong.
And one of the simplest answers has always been, God created the universe. At first, this sounds like an explanation. If the universe exists, then something must have made it. And if something made it, maybe that something was God. But almost immediately, we run into a problem. Who created God? If everything needs a cause, then God also needs a cause. And if God does not need a cause, then why could the universe not be the thing that does not need a cause? This is where the answer becomes less simple than it first appears. Saying God created the universe does not necessarily explain why anything exists. It may only move the mystery one step further back. Instead of asking where the universe came from, we now ask where God came from.
So maybe the better approach is not to begin with belief, but to begin with what we can actually study. Physics. Science has often taken things that once seemed supernatural and shown that they follow rules. An eclipse, for example, once looked terrifying. It could be seen as a sign, a punishment, or a message from the gods. But once people began to understand the motion of the sun, earth, and moon, an eclipse became something else. Not less beautiful, but more understandable. It was a shadow. That is a very important shift. Nature was not acting randomly. It was following patterns. The same happened with lightning, disease, planets, stars, and many other things. Lightning became electricity. Disease became biology. The motion of planets became gravity and mechanics. Again and again, science did not remove wonder from the world. It showed how the wonder works. So when we ask why the universe exists, science asks a slightly different question. Could the universe exist because the laws of nature allow it to exist? Not because someone outside reality decided to make it, but because reality itself has rules.
Stephen Hawking expressed this idea very sharply. He argued that because there is a law like gravity, the universe can create itself from nothing. That sounds impossible, and honestly, it should sound impossible at first. But in physics, the word nothing is much more complicated than it is in everyday language. Before getting to that, we need to ask what the universe is actually made of. At the simplest level, we can talk about three ingredients: matter, energy, and space. Matter is the stuff we can point to: atoms, stars, planets, people. Energy is what makes things happen: light, heat, motion, radiation. Space is the stage where all of it exists. But Einstein changed this picture. His equation, E equals mc squared, showed that matter and energy are connected. Matter is a form of energy. Energy can become matter. They are not completely separate things. So the question becomes even stranger. Maybe we do not need to explain matter and energy separately. maybe we need to understand the total energy of the universe. And here, there is a very strange idea in cosmology. The total energy of the universe might be zero. This sounds absurd. Stars have energy, galaxies have energy, light has energy, your body has energy. So how could the total be zero?
The answer has to do with gravity. In some ways, gravitational energy can be treated as negative energy. A simple analogy is digging a hole. When you dig, you take dirt out of the ground and pile it up. Now you have a hill above the surface and a hole below it. One is positive, the other is negative. Together, they can balance. Some physicists suggest the universe may be something like that. Matter and radiation are like the hill. Gravity is like the hole. Add everything together, and the total may cancel out. This is why the universe has sometimes been called the ultimate free lunch. It may contain enormous structure, galaxies, stars, planets, life, while still having a total energy balance of zero. That does not mean we already understand everything, but it does show that the question, where did all the energy come from, may not be as simple as it seems.
Now, we have to return to the word nothing. When most people imagine nothing, they imagine empty darkness. No particles, no light, no space, no time. Just absolute emptiness. But the nothing of quantum physics is not like that. Even empty space is not truly empty. It has fields, it has fluctuations, it has activity at extremely tiny scales. Particle-antiparticle pairs can appear and disappear. Energy can shift. The vacuum is not a dead blank. It is more like a quiet surface that is still trembling underneath. This is not just an idea from science fiction. Quantum effects of the vacuum can be measured. They affect atoms. They affect particles. They are part of real physics. In modern physics, particles are not simply tiny balls floating in space. They are excitations of fields. The universe is filled with fields, and what we call particles are ripples in those fields. So when physicists say that something can appear from the vacuum, they are not saying magic happened. They are saying the vacuum has structure. And if the early universe was once unbelievably small, smaller than a proton, then quantum effects would not be tiny corrections. They could dominate everything. A tiny quantum fluctuation could, in principle, grow into something much larger. Under the right conditions, it could become the beginning of a universe. This is difficult to picture because the Big Bang was not an explosion inside empty space. That is the wrong image. There was no empty room waiting for the universe to explode into. The Big Bang was the expansion of space itself. The universe was once in an extremely hot, dense state, and then space expanded. Galaxies did not fly away through a pre-existing emptiness. The distances between things grew because space itself stretched. But then comes the question everyone asks. What caused the Big Bang? In daily life, everything seems to have a cause. A river exists because rain falls. Rain falls because water evaporates. Water evaporates because the sun heats the ocean. The sun shines because nuclear fusion happens in its core. And if we keep following the chain backward, we eventually reach the early universe. So naturally we ask, what came before? But this may be where human intuition breaks down. Before is a word that only makes sense inside time. If time itself began with the universe, then asking what happened before the Big Bang may be like asking what is north of the North Pole. It sounds like a question, but there may be nowhere for the answer to exist. This is hard to accept because our brains live inside time. We experience one moment after another. Everything we know has a before and an after. But physics has already shown that time is not as simple as it feels.
Time can slow down. It can stretch. It behaves differently near massive objects. Near a black hole, time is not the same as it is here on Earth.
So if time can bend and slow down, maybe time can also have a beginning. And if time began with the universe, then the universe may not need a cause in the ordinary sense. Causes happen in time. Without time, there is no earlier moment where a cause could stand. No earlier clock. No first second before the first second. No hidden moment where someone had to push the first domino. Of course, people did not always think about the universe this way. Ancient myths describe the world in many different ways. Sometimes the world came from water, sometimes from darkness, sometimes from a cosmic egg, a battle, a god, or chaos.
Aristotle believed the universe was eternal. It had no beginning and no end. That idea lasted for a very long time. Even Einstein, at first, preferred the idea of a static universe, one that was not expanding or changing on the largest scale. But Einstein's own theory did not sit still so easily. General relativity showed that space and time are dynamic. They can curve, they can stretch, they can evolve. Then Georges Lemaitre, a Belgian priest and physicist, suggested something radical. If the universe is expanding, then in the past it must have been smaller. Run the cosmic movie backward, and everything gets closer together. He imagined the universe beginning from what he called a primeval atom. Later, Edwin Hubble observed that distant galaxies are moving away from us. Even more importantly, the farther away they are, the faster they appear to recede. The universe was not static. It was expanding.
And this discovery depended on earlier work by Henrietta Leavitt, who studied Cepheid variable stars. Her work gave astronomers a way to measure distances across space. Without that, Hubble's discovery would have been much harder to make. This is how science usually works. Not one genius suddenly explains everything, but many people adding pieces. One person finds a pattern, another uses it as a measuring tool, another connects it to a theory, and slowly the picture changes. The universe was not a fixed stage. It had a history. A simple way to imagine expansion is the balloon analogy. Draw dots on a balloon and inflate it. The dots move away from each other, not because they are crawling across the rubber, but because the surface itself is stretching. That is similar to cosmic expansion. Galaxies move apart because space between them expands. And if we run this backward, galaxies were closer in the past. The universe was denser, hotter, smaller. In the early universe, things were so hot that atoms could not exist. Matter and radiation formed a kind of glowing plasma. Light could not travel freely because it kept scattering off charged particles. Then the universe expanded and cooled. Protons and neutrons formed the first light elements, mostly hydrogen and helium, with a little lithium. Later, atoms formed. Light could finally move freely through space.
Over time, gravity pulled gas into clouds. Clouds formed stars. Stars formed heavier elements. Supernovae scattered those elements into space. Later, those elements became planets, oceans, chemistry, and eventually, life. So the atoms in your body come from different chapters of cosmic history. Hydrogen comes from the early universe. Carbon, oxygen, nitrogen, and iron were forged in stars. In that sense, we are not separate from the universe. We are made from it. We are star matter that became aware of itself and started asking where it came from. But the universe is not only old and large, it is also mostly invisible. When astronomers studied galaxies, they found a problem. Vera Rubin measured how galaxies rotate. According to the visible matter, the stars, gas, and dust we can see, the outer parts of galaxies should rotate more slowly than they do. But they were moving too fast. Something unseen was adding gravity. We call it dark matter. We still do not know exactly what dark matter is. It does not shine. It does not reflect light. It does not behave like ordinary matter. But we see its effects. Galaxies rotate as if they are surrounded by invisible halos. We also see gravity bend light. When light from a distant galaxy passes near a massive object, its path curves. This is gravitational lensing. It lets us detect mass that we cannot directly see. So the universe is not only stranger than ancient people imagined, it is stranger than modern people expected. Most matter may be invisible. And even that is not the whole story. When scientists studied the cosmic microwave background, they found something like a baby picture of the universe. It is ancient light from the time when the universe first became transparent, about 380,000 years after the Big Bang. Before that, the universe was a hot plasma, and light could not travel freely. After atoms formed, light was released. That light has been traveling ever since, stretched by the expansion of space into microwaves. When we map it, we see tiny temperature differences, small hot and cold spots. These are not random noise. They are clues. They show the seeds of the structures that later became galaxies and clusters.
And they tell us something even more surprising about what the universe is made of. Ordinary matter, atoms, planets, stars, and people, is only a small part of the total. Dark matter is a larger part, and most of the universe appears to be dark energy. Dark energy seems to be connected to the accelerated expansion of the universe. The universe is not just expanding, its expansion is speeding up. Einstein once introduced the cosmological constant into his equations to keep the universe static. He later disliked that move, but modern cosmology brought back something very similar, not to keep the universe still, but to explain why expansion accelerates. It is possible that empty space itself has energy, and that brings us back again to the vacuum. Quantum physics makes this even more confusing. Paul Dirac's equations predicted antimatter before it was found. Werner Heisenberg showed that uncertainty is built into nature, not just caused by bad instruments. Richard Feynman gave physicists diagrams that describe particle interactions in a simple visual language. Virtual particles can appear and disappear. Vacuum fluctuations can affect atoms. The lamp shift, a tiny change in hydrogen's energy levels, is a real measured effect connected to quantum fluctuations. So when someone says something cannot come from nothing, physics has to ask a careful question. What do you mean by nothing?
The nothing of philosophy and the vacuum of physics are not the same thing. Empty space in physics can have fields, fluctuations, and energy. It can behave in ways that ordinary intuition does not expect. But there is also a serious problem here. When physicists try to calculate the energy of the vacuum using quantum theory, they get a number that is unbelievably wrong compared with what we observe. This is sometimes called the vacuum catastrophe. It may be the worst prediction in the history of physics. But in science, a huge mistake is not always the end of the story. Sometimes it is a clue. It tells us that something important is missing. We do not yet have the final theory. We do not fully understand quantum gravity. We do not know why the laws of physics have exactly the form they have. But we have learned something important. The universe does not need a supernatural explanation at every step. That does not mean science has answered everything. It has not.
But again and again, when people once pointed to mystery and said, God did it, science later found mechanisms. Eclipses became shadows. Lightning became electricity. Disease became biology. Planetary motion became gravity. Stars became nuclear furnaces. And the origin of the universe may also belong to physics. Not because we already know the full answer, but because the evidence keeps pointing toward natural laws, fields, gravity, quantum effects, expansion, time, and energy. So, does science prove that God does not exist? No, that is not how science works. Science studies evidence. It tests models. It asks what explains observations with the fewest unnecessary assumptions. A person can believe in God for personal, spiritual, or philosophical reasons. Science cannot simply erase that. But as a scientific explanation for how the universe formed, God may not be necessary. That is the important difference. The universe can be discussed in terms of laws of nature, matter and energy, gravity, quantum fields, the beginning of time, the expansion of space, the vacuum, dark matter, dark energy. And the deeper we go, the more the old answer, because someone made it, starts to look less like an explanation and more like a name for what we do not yet understand.
But the unknown is not a wall. It is where science begins. And maybe that is the most human part of all this. The universe may not have been made for us. There may be no cosmic script, no invisible strings controlling every event, no guarantee that life has a special place in reality. But that does not make life meaningless. It makes it rare. It makes it fragile. It makes it a stunt.
One life, one planet, one universe, and a mind capable of wondering about all of it.